name is Nibras and this is Bashar. We're going to be talking about the aerodynamic designs of solar cars. The objective of this experiment is to compare two solar cars and their aerodynamic designs. To do this, we'll first introduce the topic, continue with the procedure of both inventor and ANSYS, talk about the results, discuss them, and then come to a conclusion. The introduction. What is the World Solar Challenge? The World Solar Challenge is a race that invites people from around the world to design solar cars that are both aerodynamical and run on solar power. The main purpose of this World Solar Challenge is to push innovation and solar designs to help both in solar energy and transportation technology. These are the two cars that we've chosen to model. First is car A. Car A has won in a different year than car B. They've both won in this solar challenge. So procedure. First we had to make the inventor designs, and then we had to go to ANSYS to produce the airflow diagrams. Before we could start, we had to assume dimensions for the two cars because the dimensions weren't given. So we selected a plane to work on. Then we began using the spline tool to create aerodynamic shapes for both the bottom and the side of the body. We then extruded them. Because these cars were both symmetrical, we simply mirrored the image to save time, to make sure that both sides were exactly the same. Then we added the area for the head, where the passenger would go. Then we added shape for the sides and extruded them. Then to finalize it, we filleted the edges to make it a smooth flow around it. This is car A. And this is designed for car B after following the same procedures.
Good morning, everyone. As my colleague said, I am Bashar Dadouch, and I will be talking to you about the rest of this procedure. So when we went into ANSYS, we're supposed to pick our parameters for the car and the airflow around it. We chose to pick something that is basic. So we chose ideal gas, isothermal heat transfer, and the pressure of 1 atm. And then before we could run the simulation, we had to decide on a running speed. Even though the car can reach up to 100 kilometers per hour, we chose a much slower speed so that it would be easier for us and we could use minimum turbulence. So the speed that we chose is 15 meters per second. So for the procedure itself, after importing our car into ANSYS, which is not a very easy task because you have to make sure that your inventor drawings are saved as .igs, we imported them into ANSYS and we had to create a box around our cars. These boxes are then meshed together with the car, and our forces are set up around the box. So basically, you have the box and your airflow is going to go through the box and around above the car. And then we just run the simulation to get our results. This is one of the results for car A. As you can see over here, the force is lifted up because that's how they are. They come from the front and they sort of lift it up. So we have to make sure that the weight keeps it down. This is also of car A. This is the pressure on the car. As you can see from the diagram, the colors at the front show the highest pressure. And this is one of the results for car B and the aerodynamic analysis around it. This is of our second model, which was car B, and we got a much smoother airflow of it. This is another view of the car. Our drag forces on each car were not very close. As you can see from the results, car B had a much lower drag, which was equal to 0.03 newtons. And car A had a drag of 0.11 newtons, which means car B can go faster with less required input. What we concluded from this project is we learned how to use 2 new programs for the scores. And in conclusion, we were able to design 2 cars and find out which has a better airflow, aerodynamic design. And thus we believe our project was successful. Thank you for your time.